call is now being recorded.
Have you done your homeworks? Yes, have you done? I gave two problems, right? Yes, students, have you done? I'm audible. Respond, Mipa. Have you done the homeworks? Yes, Miga. What about others? Completed. Okay, fine, ma. What about others? Have you completed the homework? This is for your practice only. Okay. Only two people's completed. What about others? Anyone is there? Okay, fine. Two people's only completed the particular homework. That is for your practicing. I gave, right? No problem. Okay, today topic is double hashing. We will see what does mean by double hashing. In the case of linear and quadratic, what we did, we just make a, we try to find another adjacent empty cell to insert the particular element, right? In the case of linear, we just inserting the element plus 1 plus 2 plus 3 like linear sequence. We are adding the linear sequence. But in the case of quadratic, what is the aim, what is our process means, we just adding the element in 1 square, 2 square, 3 square like this. Okay. So for the double hashing in the name itself, we can say this is the two hashing function. Okay, once first we use one hashing function. With the help of this only we are finding the position for that element. Okay, if collision occurs, then we can move to the next hashing function with the combination of two hashing function. This is called double hashing. Okay, it is one of the collision resolution method. Okay, or collision resolution technique. And double hashing uses the idea of applying a second hash function to the key when a collision occurs. Okay. The first step is the same thing like previous we did linear and quadratic, and here that second step only differ. We'll see what is the difference. This is the hash function for the second hash function, hash 2 of key equal to what, r minus key mod r. Okay, this is the formula. This is the second hash function. We know already what is the first hash function, how we can find the hash value or a hash key for the particular element. What is the formula for finding the hash key? Yes, students, what is the formula for finding the hash key? Basic formula for finding the hash value. Yes, respond me quick. Do fast. Number mod 10. That means key mod table size. Yes, very good. Key is nothing but the element we are going to insert. Okay, then mod operation, then table size. Okay, this is the function or formula for finding the key value, hash key value. Okay. Here also we are going to do the same formula, but if collision occurs, then we move to the next one. Okay, the next formula is nothing but r minus key mod r is nothing but key is know already. What is that? Element. We are element which we are going to insert, and r is nothing but it's a prime number that is smaller than the size of the table. Okay, previous prime number. For example, the table size is 10 means which one is the previous prime number for the table size 10? Table size is 10. Okay, is 7. Not 9, not 8 and 7. 7 is the prime number. So here, if the table size is 10, the R value is 7. Okay, is it clear? For example, the table size is 14. Then what is the R value here? The table size is 14. The what about R value? Is previous prime number. The table size is 12, sorry 14. Then what is the value of R? Is it 11? What about others? Is it 13? Others also please respond. What is the prime number? Previous prime number of 14. 43 people are in the meet. Please respond me. Only 2 people responded. Yes, Jashwant and others. Yes, that is 13. Okay. Yes, thank you. So the prime number is 13. So I need to make that particular R as a 13. Okay, like this way we can go with that second hash function. With the help of this, we can find the empty position and insert the element. This is the main formula hash key equal to key mod table size, and this h2x denoting what? In the case of linear, f of I equal to I, quadratic f of I equal to I squared. Here double hashing f of I equal to I into h2x. h2x is nothing but this is the second hash function. Okay, we'll see. Yes, please all of you try with this table size of 7. Insert the element into the hash table and tell me the position of each and every element. Go first. Completed. If collision occurs, now we are doing that double hashing. So if collision occur, we have to use the another formula. Okay. Yes, tell me for the 76 where I can insert. 6. Okay. For 93, 2. Okay. 40, okay. 47, 47, 5. So the collision occur, right? Here. Is it so? All are doing? Okay. The first position is 6th and 2 and 5th and the 4th also. We can we get the value is 5. So I can insert. I'm going to insert the element 47 into 5, but not possible. Already the 40 is inserted. So what we have to do? Go with the next formula. Next formula is nothing but R minus X mod R. R is nothing but previous prime number. Here the table size is what? Table size is what? 7. So prime number, previous prime number from 7, 5. So I can use the R, use the 5 instead of R. So 5 minus again the key mod R. Okay. So what is the value? 3. Okay. Is it clear everyone? Here the collision is occur, so I'm going to going to use the next formula, r minus x mod r. This is the second hash value. Okay, so once you go with this second formula, then we get the answer is 3. We are not going to insert the element in the third position, but we have to going to insert the element after where in previous hash 1 function, in previous function we get the value as 5, right? So we need to shift 3 places from the fifth position. Okay, 6, 0 and 1. Here in the case of 1, I can insert the value 47. Is it clear, everyone? In the case of double hashing, if collision occur, we need to go with the second formula. Okay, I will explain again. In the case of double hash, we are implementing the first hash function, that is key mod table size, that is 5. So the 5 is already occupied with the element 40, so I can't insert here. So I need to find the another empty cell, right? For that I'm using the second hash function, that is what, r minus x mod r. R is nothing but the previous prime number of the table size. Here the table size is 7, so the previous prime number is 5, so I can use the use 5 as a r. So r minus, here key value. Okay, this is the formula. So r minus, r is nothing but the 5, and the key value is 47 mod r. Okay, so what is the answer? Key value is 47, right? So 47 mod r is nothing but 5. So what is the answer? 47 mod 5. What is the answer? Students, 47 mod 5. What is the answer? 2. So here the r value is 5. So 5 minus 2 is 3, right? So I'm going to insert the particular element. Okay, now my value is 3. So previously in the first hash function I get the value is 5. Okay, in the case of fifth position only I get the collision. Okay, I need to shift. Now we got the value is 3, so I need to shift the element. Okay, I'm going to find the position, empty cell, right? How can I find? From this fifth position I need to go with 3 steps. Okay, the first one is 6 and 0 and 1. This is the third value, third cell. Okay, here the value is 3, so I need to move 3 cells. So here I can insert the element 47. Okay, is it clear, Manoj? All of you, is it clear? Nice. So the next element is 10. Again, finding the hash value, hash key. Here hash key is 3. 3 is empty only, then no problem. I can just insert the element. Okay. Then the last element is nothing but 55. Again, I'm calculating the hash value. Okay. That is 6. So already the sixth position already occupied. So I can't insert the element 55 into the sixth position. So I have to find the next empty cell. How can I? In the case of double hashing, how we can find the empty cell? Another empty cell means with the help of this formula, r minus particular key mod 5. R is nothing but the previous prime number of the table size. Here the table size is 6. So the previous prime number is 5. So we need to calculate here what is the value. 0, right? 55 mod 5 is 0. So 5 minus 0, 5. So I need to travel 5 steps from the position 6. Okay. Here only the collision occur. So I need to move forward with the 5 steps. Okay. 1, 2, 3, 4, 5. So here. So here I can insert the element 55. Is it clear? This is called double hashing. Okay, all of you. Is it clear, everyone? Okay. Is Manoj responded? What about others? Yes. Ashwin, Isak, Miga, Sandeep. Okay, fine. This is called double hashing. This in this way only we can insert. Okay. This is under the open addressing. We have two techniques. One is separate chaining and another one is open addressing. Separate chaining means we can insert the element with the help of linked list. We're just making the list, linked list, and insert the element. Linked list means we need to have two fields. One is data, another one is pointer. This pointer is pointing to the next element, and so on, like that. The next one is open addressing, linear, quadratic, and double hashing. Okay, linear, quadratic we know already. We need to, if collision occurs, we need to add some constant value. I mean linear sequence, +1, +2, +3. Likewise, we can add and find the h1, h2, h3. Once the empty cell is found, then we can insert. But in the case of double hashing, we have to use two hashing function. Once the hashing the first hashing function is nothing but the same thing, the basic formula, hash key equal to key mod table size. Okay, with the help of this we can find the empty cell is there, then we can insert directly. If collision occurs, then we have to use another one formula, that is r minus x mod r. Okay, r is nothing but the previous prime number of the table size. You have to find the prime number, and then with the help of this we can find the value. Once you find the value, we have to move forward from the previous hash function. Previous hash value is 5, so the second hash value is 3, so I have to move 3 steps forward. Okay, then I can insert the element. Okay, this is the double hashing. Next topic, next it is a simple topic, that is rehashing. Rehashing is nothing but once the table is almost full, okay, 75% full, then I can't able to insert the element. Then what is this next step? I can go with the rehashing. How we can go? If the table gets too full, the running time for the operation is too long, right? Running time also long. Then how can I implement? How can I rearrange, or how can I insert another element with the help of the rehashing? Rehashing is nothing but the name itself. We can say we need to again redefine the particular function. How we can redefine? Next prime, that is at least twice the current table size. This is the concept. Okay, for example, this is the element. Are we going to insert? Okay, the table size is 7. That means how we can find the hash function, that is x mod 7, right? X is the key element, and mod operation, the table size is 7. This is the way we can find the hash value, right? So once we go with the rehashing, how we can find means we need to double the size of the particular uh, double the size of the table size. Okay, table size, here the table size is 7. We need to double the particular table size. What is that? 14, right? If you double the particular 7, that is 14. Okay, again, what is that? Twice the current table size, and next prime, that is at least. Okay, next prime, what is the next prime of the number 14? We have to find. Okay, first you have to double the twice the table size, that is 14, and after finding the table size, we have to do what? To find the next prime number. Just tell me which one is the next prime number of 14. Next prime number of 14 is 17. So this is the answer. We have to rehash the particular table into this one. That means we are what, adjusting or increasing the table size. How we can increase? We have to twice the table size and find the next prime number for that number. Okay, so the double means that is 14, and again next prime is nothing but what? 15 not a prime number, 16 not a prime number, so 17. So this is the rehashing. Okay, we have to make the sizes larger. Okay, so for that we are increasing the table size and find the prime. This is the concept of rehashing. Is it clear, everyone? Then what is the advantage A programmer does not worry about the table system, simple to implement, can be used in another data structure as well as we no need to calculate a linear, quadratic and tabular hashing. We are just directly increasing the table size again. What? Again do what? Finding the hash value and insert the element. Okay. Totally we collapse the system. I mean stop the particular index system and finding the again new table size and insert the element. Okay. This is the rehashing. Is the new size of the hash table should be prime, will be used to calculate the new insertion. Very expansive. Okay. So now we are doubling the sizes, so I can insert 2n number of elements. Okay, this is the rehashing. That's over. Rehashing is nothing but what? Once the table is almost filled, then we can't able to insert further elements. So I can adjust the table size. How can I adjust? Just incrementing by twice. Okay, incrementing the table size by twice and finding the next prime number of that particular what particular number, that is the twice the current table size. Okay, this is the concept of rehashing. Next one, extendable hashing. This is another one concept. Here now we are going to insert the element based of binary form. Okay, for example, what is the binary form of number 4? What is the binary value for the number 4? Yes, students, are you there? Give me a response quickly. What is the binary value for the number 4? How we can represent in binary form? How we can represent 4 in binary form? Is anyone? Anyone in the meet? Respond me. What's the binary value for the element 4? I'm audible. Students, I'm audible. Yes. Yes, then tell me, Pa, what is the binary value for the element 4? How we can represent the 4 in binary format? Yes. 100 or 0100. Okay, fine. So the binary value for the element 4 is 100. We can represent 0100 or 00100 or 000100. Okay. So if I'm going to insert the element 2 into the hash table, I have to convert the particular element 2 into binary format, then only I can insert. Okay. The case of extendable hashing. Okay. Here we need to know two terms. One is directory and leaf. In the directory, we just mentioned the least significant least significant bit, and based on that particular bit, we are just inserting the element. It is in the form of tree like structure. Okay, based on the root we are inserting, right, like that. Here based on the directory, for example, if the element is starts with the 2, 20, 21, 22 means we have to insert in the same leaf. Okay, based on 20, the element which are greater than 20, I can insert in one leaf. Okay, like that. If the element is it starts from 30, 30, then 31, 32, 33, 35, like that, I can insert in another leaf. Okay, like that. Based on the directory, I can insert the element. Once the overflow is happen, then I can split the leaf into 2 or increase the directory. We will see how we can. Extendable hashing is the mechanism for altering the size of the hash table to accommodate the new entries when bucket overflow. We can say the leaf as bucket also. Common strategies in internal hashing is to double the hash table and rehash. Yes, before that we seen, right, that all under the what internal hashing. Okay, this one is the external hashing. Okay. Okay, however, in the case of internal hashing, this technique is slow because writing all pages to disk is too expansive. Okay, therefore, they are instead of doubling the whole hash table, we use the directory of pointer of bucket and double the number of buckets by doubling the directory, splitting just the bucket that overflow. We'll see what is this in next slide. Okay, extendable hashing is nothing but what we're going to insert the element based on the binary format. Okay, once, for example, how can I say? 001 directory is named as 00011011, like that it may be. So I can insert the element which are the elements of starts from 00, then I can insert under the 00 directory. Okay, which are the elements of starts from 11, then I can insert it at the last directory. Okay, like that. We'll see. It is like tree to insert keys into hash table. um, Here they are taking the 6-bit integer. That means, for example, if 4 element 4 means you have to go with 000100. Okay, this is the way we can represent here. The root of the tree contains 4 pointers determined by the leading 2 bits, leading bit, least significant bit. Okay, based on this, the root is represented in each leaf. The first 2 bits are identified and indicated in parenthesis D, represent the number of bits used by the root. The number of entries in the leaf node, this is the size. What's the size? 2 power D. D is nothing but the bits represented in the root. The root is having 2 bits, then the particular leaf having the 2 power 2 entries. Okay, that is 4 entries. If the root having 3 elements, then the leaf can insert 2 power 3. Okay, this is the way. I will see with one example. These are the elements I'm going to insert. Okay, going to make a hash table with the help of extendable hashing. This is for external hashing technique. It is used for large amount of storage. Okay, how we can insert, we will see here. This is the directory. Okay, this is the directory. Based on the directory, we are going to insert the element into the leaf. We can say leaf as bucket also. This is the directory, this is the leaf or buckets. Okay, based on the first 2 elements we are going to insert. Okay, 0001 1011. If the any element is starts from 11, so I can insert here. Okay, if any element start with 01, I can insert here. Okay, this way. If again the size of the particular leaf is depend on 2 power D. D is nothing but number of digit in the root directory. Okay, so what is the size here? This is the root directory. How many bits? 2 bits. So I can say the what 2 power 2, that is 4 number of entries I can able to insert in the particular leaf. Okay, once the leaf is overflow, that means another one element is coming with a 00011100, like that, anything it may be. Okay, if I'm going to insert another one element 001 1100. Okay, the element, this element I'm going to insert. Okay, for that, where I can insert here only, the element is to start with 00 only, so I can insert here. How can I insert? Means I have to split the, it is like B tree. Okay, I have to split the particular node into particular leaf into 2. Okay, 2 partition, you have to make a 2 partition and I can insert. Okay, so how can I divide? I can make the particular leaf into 2 and I can insert. See with another one example. This is the root. This is the directory. Suppose to insert the element again with the same example. Okay. Again, I'm suppose here I'm going to insert the key, this one, where I can insert here, right? Here. So I can insert here, but not possible. That this is overflow already for. So split this leaf into two leaves which are determined. Okay, how we can this way. Okay, this way I can determine. I can divide the three is divided into two parts. Okay, and the directory also what increased. How means this is called the 2 is here mentioned, right? This 2 is called local depth, and here the size of bits is called global depth. Okay, this is also 2, this is also 2. Once the both are same, insertion the overflow is happen here. See here, this is the 2, depth is 2, here also the number of bits also 2. Once in this case the overflow happen, then we have to increase the directory also. How we can increase? Just we can add another one digit before the particular element, 000. In this 3 digit, how many elements we have? 2 power 3, right? So I can go with 8 number of directory. Okay, this way. 0 I can add another one integer. Based on this I can insert. Okay, so here just what dividing the particular this third leaf into 2, and so increasing the directory. How we can increase? We just adding the particular bit into 3. We are just having 2 bits, right? So I can make it the particular 2 bit value into 3, that is 3 0 0 0 0 0 1 0 1 0 1 0 0 1 1 0, like that. I mean 2 power 3. Okay, 0 up to 3, 2 power 3 we can represent. 0 to 2 power 3 means 0 to 8. Okay, just doubling the directory, and split the particular leaf also. The leaf is splitted. Okay, here they are mentioning 3 3, but here mentioning 2 2 means this is nothing but this saying that I'm just taking the element based on first 2 bits. Here just I'm inserting the element based on first 3 bits. Okay, that's why they are mentioning. Now the 2 bits is over, right? Overflow is happens, so just I'm increasing the directory, and the leaf is divided into 2 parts, and based on the 3 bits I can insert. Once the overflow in the 2 bits, then I can go with the 3, and once the overflow in the 3, then go with the 4 bits. Okay, like that we can insert. This is for not a smaller amount of element. This will help in bigger storage. Okay, we have a larger we can tremendous amount of elements we are going to insert, or we are going to make a hashing table. Then we can insert we can use this extendable hashing method. Okay, once the overflow is now over, now the my directory is 3, right? Having the 3 bits, based on the 3 bits I can insert, but the first this leaf is inserting the element based on first 2 bits. Here also first 2, but it's 3 3 and 2. Again I'm going to insert another one element, means here I'm going to insert another one elements. Now overflow happen. Then what is the process? I just comparing the bits. Here 3 bits, here 2. So no need to increase the directory. We just splitting the leaf into 2 and insert the element. Okay, like that. Again here if I'm having here considering 3 bits, based on the 3 bits the elements are inserted into these 2 leaves. Now here if overflows happen, here 3 bits are inserted already. Again I can insert another one element, and again if another one element also coming to this leaf, means what is the process? I just here also once the both the leaves are filled, again another one element is coming, so that is called overflow. Here overflow happen. What is the next step? I can increase the directory by assuming each element 4 digit. 4 digit means what is it? 2 power 4 16. So 0 to 16 I can have the directory as 0 to 16, and based on that I can insert the element. Okay, the leaf also. splitted. Okay, this is the concept of this is the this is the concept of extendable hashing. Is it clear? Extendable hashing is nothing but it's based on tree. We having one directory, and based on the directory we have leaf no leaf bucket, or we can leaf node or bucket. We can insert the elements into the bucket based on the directory. The first, we are considering the first two bits. Based on the two bits we are inserting the elements into the bucket. Once the overflow is happened, then we are doing what, checking with the condition what number of bits in the directory, and uh, the element considered in the leaf, that is this is the number of bit in the directory, this is the element considering. Based on the two bits only we are considering and inserting the element. So both are same. We need to do what, need to increase the directory and leaf also. Increase the directory into 2 power something, 2 power 3. Here we are having the 2 power 2. So again increasing into 2 power 3 and splitting the particular leaf into 2. Okay, where the collision is occurred, that particular leaf only splitted into 2. Okay, but here in this case, this is not in the case, means another one case is what, if I'm going to insert another one element. Okay, for example, here if I'm going to, in this case, the bit number of bits in the directory is 3. Here I'm considering the element first two bits only. I just considering and inserting the element. So comparing both the things, the root directory is bigger. Okay, somewhat higher. I mean 3. So what is the next process? If I'm inserting one element here, the overflow will happen. So once the overflow happen, we just comparing these two bits. The root directory is greater. So what is the next step? No need to increase the directory. We just splitting the particular leaf into 2 and insert the element. Okay, these are the two cases in extendable hashing. Okay, that's all about our fifth unit. I will upload PPTs in the Google Classroom. Please refer. If you have any doubt, please ask me. Okay. Searching, linear and binary searching. Okay. Then sorting algorithm. That sorting, we've studied about bubble sort, insertion, selection, shell sort, and radix. Okay. After that, we're coming to the hashing function. We are going here, hash function, hash table, collision resolution techniques, or open addressing and separate chaining. And separate chaining, we can use the linked list. Open addressing, we have three methods: linear, quadratic, and double hashing. After that, we studied about rehashing and extendable hashing. That's all about 15 unit. Is it clear, everyone? If you have any doubt, please ask me. I will move on to the lab program. Have you completed all of you up to part 11? No other go. You will have to complete all the programs. Is all of you completed up to part 11? Is Miha completed? Others? Have you completed? Why you are lagging in assignment, mini project, programs, everything we are lagging? Why? Please make it fast and try to complete. Yes. Leela Krishna completed, Narasimha, Rajeshwari, Rajalakshmi is very good, ma. Pavitra, Sujita, Ritika is very good, all of you. Abhishek, good. Yes, Jashwant completed. What about others? Please log into our skill rack and try to start your try to complete all the programs. Others, I give me 2 minutes. I will go come up with another concept, that is the part 12 program. The part 12 is nothing but heap operation. Already we know, right, what is the concept of heap operation? How we can insert the element into the heap operation and how we can delete heapify operation, right? With the help of the heapify, we are checking the heap property, right? So the 12th program is that particular heap program, and 13 is DFS and BFS. We know already all the topics, all the concepts are explained. Again, I will explain the concept. Please, all of you try to complete that particular program. If you have any doubt, please contact me. Then only I can help you. No other go. You have to complete all the programs up to part 12. Sorry, part 14. Okay. In part 14, we have programs in sorting algorithm only. Okay. Other than that, sorting is no issues. You can go with that sorting algorithm, and concepts also explained. Try to implement. I'm also help you. Some people are completed all the programs. Very good. Yes, all of you, please open your Google, sorry, SkillTrack account, and complete all the programs. Those who are not completed up to part 11, I will check who are not completed up to part 11. Wait a minute. Any doubt? Anyone having any doubt? Yes, Mohit, I completed 12, 13, and 14. I have an error in yes. Which program having error? Update me, Mohit. I will help you. Others also, please interact with me. Then only I can help you. Having any error? Which program, Mohit? Which part? Okay. Binary search tree. Okay. Is part one all are completed? Okay. Anyone started record work? Okay, Mohit, you try. Otherwise, inform me. I will help you to find the errors and complete. By tomorrow, all of you need to complete all the programs up to. Okay, Mega, I will upload in Google Classroom. Otherwise, I will send to you. Is part 2 also? All are completed. Santosh and Sanjay not completed the part 3, right? Why, pa? Having any error, you can ask me, na? Try to complete, Santosh. Is Sanjay, what about you? Completed? No, Sanjay, it's showing that one program not yet completed in part 3. You have completed one, in part 3, we have 2 programs. Okay, Santosh. Yes, Sanjay, in part 3, we have 2 programs, one program only completed. Complete another program also and update me, both of you. In part 4, Kiran, one program not yet completed, pa. Rohit and Shakti Sharan not yet started part 4. Doing. Okay, Kiran. Complete soon and update me, all of you. If you are not done any one of the program, please immediately complete and update me. Okay. Shakti Charan, why not yet started part 4, Shakti Charan? What's the problem? Yes, Rohit, what about you? Shakti Charan, immediately complete all the programs where you are lagging. Yes, started. Okay. Lagging and update me, Shakti Charan. Once you done. Yes, Rohit, are you there? Rohit. Rohit is not available. Yes, Rohit is not available. Please inform him also. No other good. By tomorrow, you have to complete all the exercises. Kiran, complete immediately and update me. Okay, Kiran, complete. Part 5 is again Sakti Charan. Why, pa? Kiran also 2 programs. Both of you, Kiran and Sakti Charan, complete the part 5 also and update me. In this class, update all the complete all the programs and update me. 3:30 you have to report. Okay, what are the programs you have completed today? Part 6. Nisha, not done one program. Nisha, are you there? Why, Nisha? Nisha, respond me why you're not done one program in part 6. Nivedita, not done. Santosh, not done one program. Again, Kiran and Satticharan. Both of you, Kiran and Satticharan, stay in meet and complete all the program and leave. Okay. Yes, Nisha, Nivedita, Santosh, try to complete one program you left in part 6. Nisha, Nivedita, are you there? Respond me, ma. I'm audible, right? Students, I'm audible, I'm connected. Yes, ma'am. Thank you, thank you. Yes, then respond me, Nisha and Nivedita. Not in the meet. Nisha and Nivedita. Put absent for you. Friends, please inform her. Inform Nisha and Nivedita to contact me. Anyone? Okay. And Santosh, Kiran and Sakticharan, please complete the part 6. Part 7 again Kiran, Nisha, Nivedita, Rohit, Sakticharan. என்ன பண்றது இவங்கள? Anyone informed Nisha and Nivedita? Yes, Mohit, one program left in part 7. Prithvi, one program left. Sai Praveen, one program left in part 7, not done. Rakshini, one program not done. Kiran and Sakticharan not yet started. Nisha, Nivedita, Rohit also not yet started. Okay, Rakshini. For sure. Okay, we will see. All of you complete and update me. These people, Mohit, Prithvi, Sai Praveen, Rakshini in part 7, one program left. Kiran, Nisha, Nivedita, Rohit, Sakticharan. Okay, Sai Praveen. Nivedita, where you went, ma? I'm calling you, but no response from you.
Sumita ma'am, Rohit is on leave today, ma'am.
Okay, ma'am. Thank you, ma'am. Okay, not working, then no problem. You can put in the chat, na. Put a message in chat, then only I can understand. Hmm? Always come with any reason, any one of the reason, no problem. That is okay, no problem. That is important. You please, all of you, complete the program. That is important. Why, Nivedita, you not done the particular part 6 and 7? Nivedita, now part 7 not yet started. By today, how many today will coming? I don't know. Always you are saying today I will complete and by Sunday I will complete, but no one follow the promise, right? Part 7, we'll see Rakshini. Part 7. Okay, completed, yes. Mohit, Prithvi, Sai Praveen is only there on program, and Kiran, Nisha. Yes, have you anyone informed Nisha? Part 10 did not clear the errors, okay. You can inform me, then only I can know what is the error going and how we can rectify. Try to rectify by your own, otherwise inform me. Yes, clear the error and update me, Sai Praveen. Nivedita, by today how to complete, okay. Okay, anyone informed Nisha? Yes, anyone informed Nisha? Nisha, are you there? Yes, she has joined the meet. Ask her to respond me. Okay, part 7. Then part 8. In part 8, Sanjay 1 program not done and Teja 2 program not done. Pradap 3 programs, Predashni 3 program, and hereafter not yet started. Mohit, Kiran, Prithvi, Sai Praveen, Nisha, Nivedita, Praveen Raj, Rohit, Sai Sylvia, Santosh, Swaminathan, Sakticharan. Not yet started. Part 8. I'm believed you in your words. You said that by Sunday I will complete, by Monday I will complete like that, but no one follow the words. Santosh, what's your problem, Santosh? You can complete, right? Why I need to explain all the concept and programs to you peoples? You are not responding for my words. If you got any error, then you can inform me. Then I will update or I can give any suggestion to rectify that error. Just simply saying I'm having error. Is program means we may get some errors. Many times I informed you. Complete all the programs. Is part 9 Mohit not yet started. Kiran, Teja, Prithvi, Sai Praveen, Nisha, Nivedita, Priyadashni, Praveen Raj. Why? Sakti Charan, Swaminathan, Santosh, Sylvia. மேம் பாட்டு சொல்லிட்டு கூட நம்ம பாட்டு நம்ம வேலையை பார்ப்போம்னு இருக்கீங்களோ? You have to complete by today. No other go. Based on your performance only and your programs and output in lab, I'm the in charge for DS lab, right? Immediately complete all the programs and update me. Otherwise, I will make a note of you. Frequently, I'm telling, but no one consider the particular task. Complete all the programs up to part 14. No need to explain for you. Any use of explanation? No. The same people repeating this. Part 10. You see. Yes, Kiran, Teja, Prithvi. Okay, I will note all those things. Isaac, Monish, Sai Praveen, Nisha, Nivedita, Priyadashni, Praveen Raj, Rohit, Sylvia, Santosh, Swaminathan, Sakti Charan. Not yet started. Why I need to explain all those things to you? Explained in theory and so the programs also. Part 11. Manoj not done. Mohit again, Kiran, Teja, Prithvi, Monish, Isaac, Sai Praveen, Yashwant, Nisha, Nivedita, Jashvita, Priyadashni, Rohit, Sylvia, Sanjay, Sandeep, Santosh, Swaminathan. I don't know why you people. Sakti Charan, have you completed this part 11? Always you people saying I will complete by today, I will complete by Sunday, I will complete immediately. For sure, I will complete, but no use. All are doing? Complete and update me. I have a plan to explain part 12, 13, and 14, but now not interest to explain. But why means you people are not responding my words. By today, all of you try to complete all the programs and update me. No other go. Just showing that part 12, 13, and 14. Part 12 is nothing but implementation of heap operation. We know, right? Heap concept. We can make the min heap or max heap. In this program they are making that min heap, and how we can do, just inserting element one by one, and we need to check the property, that complete property and heap property. But complete property is nothing but how to insert the element from left to right and level by level, and heap property is nothing but if we are making the min heap, then we have to keep the minimum element in the root compared to the children's. Okay, and if we are creating a max heap, then the maximum element should be in the root node. This is the concept. Based on that we can insert the elements and do the operation. Once each and every insertion we have to check the condition as what heap, whether the particular tree is following the heap property or not. Heap property is nothing but min heap means we have to keep the minimum elements at the root, and max heap means we have to make the root element as the maximum one. Okay, once insertion is over, we have to check the particular property. The property is not following, then we have to make some operation and make the tree as heap property. That is, which operation means heapify. With the help of this we can make the particular tree as heap property. How we can do, check with the particular root node and swapping the elements. Okay, keep on we are doing until reach the heap property. This is the concept, and for this we need to know what, how we can find the parent node, how we can find the left child and right child. Okay, if the for this already we have for if the heap is starting from 1, then we can find the root element as I. Okay, index. With the help of this formula only we can find the root element and left child and right child. For finding the left child, 2I. In this program we just start from 1 size 1, from size 1. So we have to use this formula. Root is I, left child 2I, and right child 2I plus 1. With the help of this we can find the left child, right child. Okay, this is the formula. This is the input and output here. How three cases. One is the query type. One is for insert the following integer into the min heap. Here we are going to generate the min heap. Okay, what is mean by that? You have to keep the minimum element at the root compared to the children. Okay, and second case is nothing but we are going to delete a minimum integer. In the case of deletion, we have to make the delete the minimum element only. And third case is for print all the integer. Okay, in the level order, we know what is made level order, right? So these are the three operation implemented in this program. Number of element given is 22. One is nothing but the element we are going to insert. Now the option is one, going to insert the element. Which element? That 9. And second also insert the element 8, 7. Please all of you make a tree for this element and check with the output, and then you go with the program. Okay, 9, 8 answer. First you insert the element 9. You know, right, how we can make a min heap, how we can create a min heap. First you have to insert the element 9 and 8 in the left side of 9 and 7 in the what sorry, once insert and the 8 is inserted, you have to check the heap property. The 8 is smaller than 9, so you have to swap the elements. Okay, and insert another element and check again the heap property, and if it is not following, then you have to change, I mean swap the elements. Okay, like that you can insert. The option 3 is nothing but printing the elements in the form of level order. 2 is nothing but is for deleting an element. This is the program for heap min heap creation. How we can insert the element? Just increasing the heap size and inserting the data. Okay, index is nothing but heap size. If you are having only one element, that is called zeroth element. I mean here starts from 1, so it is called root node. Index equal to 1, and index by 2 is nothing but it is a formula for finding the root element. Okay, index parent position. If I want to find the parent position, then for example, for f, what is the parent? This c, right? So we have to calculate parent position equal to I by 2, that is 6 by 2 equal to 3. So that we can find the parent of the particular node. For example, if you're taking the node d, means how we can find the parent node? 4 by 2, that is 2. In the position 2, the parent node is inserted like that. So we give the help of this formula. If you are going to find the parent position, I by 2, left child 2i, right child 2i plus 1. With the help of this formula only we can insert here. So once this is index by 2 is for finding the parent position, the particular parent element is greater than data, then what we have to do? We are going to create a min heap only, so we have to swap the element. Okay, parent data will come to the index, and index is assigned by the data. Okay, is it clear? This is the way they are inserting the element. And display is nothing but just to start from index value and up to heap size, printing the data. Swapping here function for swapping, we know swapping function, right? And heapify operation. What does mean by heapify? We have to find the minimum value. We have to take one element and compare with the root node. The element is minimum, then we have to swap the element. Otherwise, no need to swap. Okay. For that, we are minimum is assigned by parent is assigned to minimum, and left child 2i. Minimum is nothing but parent position, so we can say 2i plus 1. Okay, already I've shown that formula. Left child is less than heap size, and the particular child is less than heap of minimum, means I mean particular element is less than the parent node, then we have to assign the particular left child as the minimum one. Okay, that means the parent is greater, so we have to replace the parent with the left child, otherwise we go with the right child. The minimum not equal to parent, then swap the element. Okay, this is the keepify operation. Again it recalling the same function, recursion. And deletion, how we can going to delete? We just do what? Last element, we can make the deletion at the last element, right? We have to shift the minimum element, I mean parent element, to the last position and delete the element. This is the main function. We are just checking the condition. This one is insertion, calling, deletion, and display. This is keep. This is the part 12 program, and 13 is DFS and BFS. You know the concept of BFS and DFS, right? Part 3, sorry, 13. Once you complete any of the program and update me, try to rectify the errors. The 13 port is BFS and DFS. The first one is BFS. How we can implement BFS, we know already. We need to start with any one of the vertex and visit the adjacent vertices and insert all the adjacent vertices into the queue, right? We visit all adjacent and then select among any one of the adjacent and visit the same, repeat the same process. I mean, go with the adjacent of that particular node and keep on doing that until visit all the nodes. This is the concept of BFS. Start with the starting any one of the vertex and see the adjacent for that particular vertex and insert all the adjacent into the queue, and one by one we dequeue that element, and so see the adjacent for the particular inserted node also. Okay, like that we have to move until we reach the unvisited node. We need to visit all the nodes one by one. This is the concept here. They are implemented with the input, I mean the connection also uh, asking from user based on this matrix representation. They are giving not give any diagram or a graph, just with the help of adjacent matrix, right? Here this is for the example of 4 nodes and 2 is the starting vertex. This is the first row, shows that the connection is established. Is it any connection between the node 1 and 2? Then it is we can assume that we can give the value as 1. There is no connection means we can give the value as 0. Okay, for that first row, it having the value of 1 0 1 1. This means that there is a connection between 1 1 1 1 1 means self loop. One connection between self loop, self loop is there between the node 1 and the second one is 0. That means that there is no connection between 1 to 2. Okay, and if they are mentioning directed weighted, you have to do, otherwise no problem, we just make a connection only. And the third element 1, so we can assume that 1 to 3, the node 1 to node 3 having connection. and the fourth one is also 1. So we have one connection between node 1 and 4. Okay, like that it going. This input is given from the user. We can get this input in the form of two loops, okay, row and column like matrix. You can fetch the data, and the output is nothing but is the visited order. Okay, first we start with the starting with us, they are given, that is 2. With the help of this we are moving one by one and visit all the vertices. Okay, how we can do, how we can add the elements into the queue with the help of this formula. Once you start with the start vertex, I mean starting vertex, then you have to find the adjacent vertices for the particular vertex, right? So once you find the adjacent vertices, you have to insert the adjacent vertices into the queue with the help of this uh, lines. With the help of these lines we can insert the adjacent vertices into the queue. Okay, the simple concept already we have studied in the queue, just incrementing the value and assigning. There is no element in the queue, then we just make the particular element as a uh, first element, and otherwise increment the real value and insert the data. Poll is nothing but is called deletion or NQ, DQ operation. Okay. Then main function, in that main function, uh, doing what, just asking the row and column. Row and column represents the matrix, adjacency matrix. With the help of this we can draw the diagram, right? If the connection is there between two nodes, then we can make it as a 1, otherwise 0. It should be in the form of a particular boundary. We have to check the source vertex also. The source vertex is between the, is it so? I forgot to share. Then no one listening. No problem. Thank you, Nitish. Main function, they are checking the condition. Okay, then get the data, I mean adjacent matrix, with the help of these two for loop, and store in this adjacent matrix variable. And we have to check the condition here. If the particular row and column particular value is not equal to 0 and not equal to 1, then invalid matrix. Okay, I mean that the matrix should contain the value 0 or 1. Okay, if it is 0 means there is no connection, 1 means there is a connection between two nodes. Okay, if both the things are not there, then this is called invalid matrix. Here in this case, BFS we have to go with the zeros and ones, right? And here we have assigned the creator one variable visited n plus 1. This is nothing but we are just, once the particular node is visited, we have just stored the particular vertex into the visited matrix. Okay, here initially it start with 0 visited. Once the source vertex is visited, we just make it as a 1, add the source to the particular matrix. Okay, visited node, the add the source vertex into the visited node. Keep on, we are moving and finding the what visited node. How we can how we, here we are seeing that adjacent vertices for the visited node. Okay, this is the process of BFS, right? Once we need to visit the source vertex, then we have to find the adjacent vertices for the source vertex. How we can find? With the help of this formula. That means if equal to 1 means what is that, then only we can assume that a connection, right? So for the vertex, for example, the vertex 2 is source vertex. Okay, the source vertex is visited. Now I'm going to check what adjacent vertices for the particular source vertex. How we can find? We are going with matrix only. Then how we can find? If the value is 1 between the two nodes, then only I can assume there is a connection. Okay, so I need to check with that condition, particular value equal to 1, then that is called adjacent vertices. And again need to check another one condition, that visited of equal to 0. We need to check the adjacent vertices, and so the particular adjacent vertices not visited already. Once it visited, no need to visit again, right? So I need to check with that visited of column equal to 0. Okay, this means that there is a connection is there. I mean, this is the adjacent vertices but not yet visited so far. Okay, this is the for this condition means that, and both are true, then I can add the particular vertices into the visited. Okay, this is the process. This is the BFS. Make a note of it, this program, and complete. The next one, DFS. Here also the same concept, only the difference is here we are putting the values in the stack, and the same condition you need to check with that the value is 1, the matrix should contain 1 and 0. If not, then we can say sorry, this is the concept of what finding the adjacent vertices, whether there is a connection and already not yet visited. Okay, check with that condition. If it is both are true, then I can include the particular vertex into the DFS. In main function, we are checking the condition and getting the elements with the help of this for loop. Here only they are checking the matrix should contain 0 or 1. 1 means there is a connection, 0 means no connection. Okay, if visited, all the nodes visited, no problem. Otherwise we need to check the condition with the for loop. Visit all those things with the help of source node and the connection. This is the same program, only the small changes between the BFS and DFS. The next program, the 14, is the shorting algorithm. On it, I will show again. Anyone completed any one of the program? This lab? Anyone completed? Yes, Isa completed part 10. Okay, very good. What about others? No one completed, right? Which program, Ashwin? Which program? 14th. Okay. In 14th, we have 6 programs, right? 3, 1, 2, 3, 4, 5, 6 programs. Which one? Okay, Mika. Today complete and update me, Mika. Is Ashwin, which part, which program you having error? The first one is count the number of elements. Second program, right? Okay. Okay, Ashwin, I will explain with that program. The first program is nothing but find the number of occurrence in the integer. Okay, simple program, no need to explain. All of you, please try. It's a very, very simple program. All are doing skill track, right? Are you doing skill track regularly? Yes. Okay. Please do skill track regularly, then only you can improve your programming skill. Okay, don't waste your time and money. All of you, please take skill track regularly, then definitely you will get knowledge in program. Okay, the first program, find number of occurrence. For example, here the input given as number of integer is 5, and these are the values. They are asking which one is the last element and count number of occurrence of the last element. Okay, here the last element is 14, and how many occurrence? 1, 2, 3. So output is 3. How we can do? Just we get the elements, main function and boundary, checking the boundary, and with the help of for loop we are getting the element and checking again the condition if it is in integer. And how we can do? With the help of for loop we are doing what? Array of index equal to array of n minus 1, comparing the element, both are same, check with one element to the next element. If they are same, then counting, incrementing the count value. Okay, this is the first program, so simple. The second program, count n integers in m integers. That means here they are giving two arrays, one array having 7 elements and second array having 5 elements. Compare both the elements and find how many elements are same. How many elements? Yeah, 1, here also 1, 1, sorry, 1, then 18, no, 9 is also there, right? Then not available, 11, 14, 20. Okay. This one is in two position here and there, and again the 9 is available. So the value is 3. There are 3 integers in the second line which appear in the first line. Okay. 3 integers in the second line which appears in the first line. Is it clear? How many integers appears in the first line, which is already occurred in the second line? This is the meaning. So 191 occurred in the 191 occurred in that first line. Here they are mentioning in two elements. One is in two position, second position, and it's last position, but it is occur here. So we can say 1, 9, and 1. So the value is 3. Output is 3. So how we can implement this? First, arranging the element sorted order, checking the condition, and with the help of for loop, we are just arranging the elements. Calling here the one function sorted array. We will check what is this. In main function, just they are checking the condition. Sorted array is a default function, right? They are using. Ashwin, check with your code. Okay, here they are finding, calculating the occurrence. Okay, how they are doing. The input is array and size and search value. We are going to search the value which is in the second line. Okay, the element which is in the second line, whether it is whether the particular element is available in the first line. How we can check with the help of left. While left less than or equal to right. Okay, you're checking one condition, one left equal to 0, just start with the first element, and right equal to size minus 1. If the size is 12, then we can have 0 to 11 elements. Okay, so that we are checking that condition. While until reach the last element, we are doing what? Intermediate equal to left plus right less than 2, and search the element. Okay, if it is, we are just arrange the elements in sorted order, right? So we are checking with the, we are finding the middle element, and the particular element is less than the middle. We are going to check with the left side one part of the code, otherwise we go with the next part of the code. Okay, this is the concept. This is the way we can find the elements, okay, which is available in the first line. The next one, bubble sort. How we can do the bubble sort? We just taking the one element and compare with the adjacent element, and if it is a greater, we move to the next, bubbling the bubble, just bubbling one by one step, and reach at end of the first pass, the highest element should placed in the last, I mean rightmost side. Okay, this is the bubble sort. How we can do? Just we are taking the position index equal to 0. Okay, and here the CMP index also 0. Yes, index also 0, CMP, this is the two variables we are comparing. Do what? Array of CMP index greater than array of CMP index plus 1. That means the value which is in the 0th position, the value which is in the 1th. Okay, the 0th position element and first position element we are comparing. If it is greater, the 0th element is greater, we are just swapping the element. This is for nothing but just printing the index, printing all the elements in the particular array of list. Okay, list, we are just printing the all the elements. Okay, this is the bubble sort. For the swapping, we are just having one function in main function, just comparing the element and calling the what? Bubble sort. How we did the bubble sort? We just taking the first index element, taking the 0th position element and first position element and comparing both. If the 0th position is greater, we shifting the element, just swapping. Like that we are doing up to n elements and get the bubble sort. Sorry. So this is the bubble sort. The next one, which is insertion. Okay, the next one is the insertion chart. How we can do the insertion? It is like playing a cards, right? We just assume the first node, first element is the shorted, and compare with the next element and arranged in order. Pick the next element and arranged in order. Find the correct position and insert. Okay, this is the insertion chart. This is for display the elements, printing the integers. Here the actual function is happening, insertion sort. How we did, just taking the position. With the help of this only we are doing. Here we start with the index 1. Okay, index 1, and array of index, I mean array of 1. Here the index is given into the current value. Array of 1 is given to the current value. CMP index nothing but index minus 1. That is the starting the if example the array starts from 0 to n number of elements, right? So we just make the first element in the CMP index and second element in the CRR value, current value, and comparing both the things. If CMP index is greater than 0 and array of CMP index is greater than current value, we are just swapping the elements. Is it clear? So we just doing what? Comparing with the adjacent element. CMP of index is greater than 0 and array of CMP index is greater than current value. Okay, current value is nothing but having the value of the index minus 0, that is 0. Index is 1 and minus 1, so index minus 1 is the 0. This is the value of first element, this is the second value, second element, and comparing both the things. Both are the current CMP index is greater, I mean CMP index nothing but the first value, index minus 1, so 0. Array of 0 is greater than the current value. If it is greater, just we are doing what? Swapping. Otherwise we make the current value in the next position. Okay, this is the concept of insertion, other than same like bubble. Next one, merge sort and quick sort are not in our syllabus, but they are given that program. Merge sort is nothing but we just using the concept of divide and conquer. If you are having 8 elements, just divide it into 4 4, and again 4 elements is divided into 2 2, and divide the particular 2 element is into 1 1. Okay, up to reach the smallest unit, you may divide. You can divide up to reach the smallest unit. Smallest unit is what? Until 1 by 1 we divide all the elements into 1 by 1. After that we just merge the elements 1 2 1, like that. I have one okay, this is the insertion sort. Just dividing the particular whole elements into 2, sorry, merge sort. Okay, dividing the list of elements into 2, and again dividing this into 2, again this divided and 2, until reach the smallest unit. Okay, smallest unit means until reach the 1. Now what's the next step? Again we are merging. This 14 and 7 is merging, and again 3 and 12 merged. Once you go for merging, then you have to arrange the elements in order. Now I'm going to merge the element, what, 14 and 7. Okay, how can I merge? I can merge and give in the order of 7 and 14. Okay, once in the case of merging, you have to go with the order, I mean shorted order. And 3 12 is no problem, we just merge the 3 and 12, and 9 and 11 we just merge, and 6 and 12 it is need to swap. We merging by 2 6. After that, now the elements 2 2 added again. The same procedure, we are just dividing 8 into 4 4 and 2 2 1 1, like that. Now we are merging the same way. 1 1 is added into 2, and 2 2 added into 4, and 4 4. Finally we have the 8 elements. If you have any doubt in this, please ask me, I will explain after the class. Or okay, this is the next one, is the quick shot. Quick shot is nothing but we have to take one element from the list of elements. You may take the first element or last element, no problem. You have to pick any one. This is called pivot element. We consider that particular element is a pivot. Based on that element, we are arranging the elements, compare with each and every. We are here taking the 70 as the pivot element and comparing with each and every element. The element is smaller than the pivot, then we can make it one array, and if it is greater, then we have to make in another array. And again, now we having 4 element. In that, you have to pick one pivot element, doing the same process. Is it clear? This is the way we can arrange. This is the quick sort we are implementing here. If you have any doubt, other concept are explained already. The merge and quick sort is newer and not in syllabus, but skill track, in skill track they are given. So if you have any doubt in merge and quick sort, please ask me in the case of coaching class. Okay, after 4 o'clock today we have coaching class. I think so. We have coaching class. If you have any doubt, ask me. I will explain again. Okay. The quick start, they are doing what? Selecting one pivot element. Based on that, we are dividing the whole set into two until pivot element and after the pivot element. Like that, we can divide. Then again, this is a recursive process. Again, one set is divided. In that particular set, again we are finding the pivot element and doing the same process. Compare with each and every element with a pivot element. If it is lesser, make particular element into one array, and if it is greater, and make that particular element in the next array, like that. Okay. Like this array of left is less than pivot, and increase the left side, otherwise right. If it is greater, then decrease the right side. Okay, just moving both the ends. This is the quick sort algorithm. Merge sort, already the concept is clear, right? Divide the 8 into 4, 4 into 2, like that, and combine the same way. 2 into 4 and 4 into 8, like that we can combine again. Okay, this is the merge sort. Here we just finding the how we can divide the elements with the help of midpoint. We just finding the midpoint we can find with the help of left plus right divided by 2. This is the formula. Left right is nothing but the index. Left index means leftmost index. The 0th index, it may be the value, that is the 8th index or 7th index. Adding both the things and divide by 2. This is the mid value. Based on the mid value, we can divide the particular array into 2. Both are merge and quicksort. Both are following the concept of divide and conquer only. Again, the recursive process, again where they are dividing the particular 4 into 2. Okay, like that, until reach the smallest unit. Okay, and checking the condition whether the particular start 1 is nothing but left side, first element in the one array, and the start 2 is nothing but the left another next first element in the next array. Based on they are comparing, okay, and adding. First they are dividing, right? First they are dividing with the help of this function, and merging with the help of this function, checking with the condition and inserting. Okay, this is the concept of merge sort. Try to implement all those things. If you have any doubt in merge and quick, I will explain again. Otherwise, I will if you are asking, then I will explain detailed manner of merge and quick sort. Okay. Anyone complete? Anyone completed any of the program? Okay, Santosh. What about others? Working in part 11, any error you can't able to rectify, please update me. I will help you. Okay, all of you. Up to 11 completed. Okay, Sanjay. Complete others also. I will check again. Okay, Narasimha. Complete 13 and 14 also. almost by today complete all the programs up to part 12. Tomorrow we have second hour. I will go if you have all of you completed, then I will go with that review of all the 5 units. Okay, if not completed, then I have to struggle with the skill track program, and you, all of you. Okay, please try to complete, try to rectify the errors. If not possible, update me, I will check and guide you. Is it clear, everyone? Try to complete by today, no other go. All of you, please complete by today. If you have any error, can't able to rectify, then inform me, I will guide you to complete. Okay, we'll check again that skill track status. So tomorrow we have second, right? Please, all of you go through all the units. If you have any doubt, uh, ask me. I will explain. Otherwise, I will go through all the 5 units. Okay. If you all completed the skill track program, then only I can go with a revision, right? Uh, after hereafter, I mean, from next week, I don't know. They are scheduling the class or not. I don't know. Please, all of you complete by tomorrow all the programs. Today evening after the 3:40, please all of you try to complete. If you have any doubt, please ask me, I will help you. Repeatedly I'm telling, try to complete all the programs. Today I will upload the 5th unit PPT and class video in that GCR. Okay, and so please try to start our record work also. Try to start with aim and algorithm. Some people having the sample report, right? One people you may have, right? You may ask with your friends IT department and ASBS. Okay, okay, Isak, I will upload. Your friends also having, your classmates, some people having that record of some people. Yes, that in that particular department, they are the people's completed. I think so. Kiran, have you completed any of the program? Kiran Sakti Charan. Is Kiran Sakti Charan is there? Respond me. In class starting, I have asked both of you. Thirty-seven people only there. Some people left. Why? Once you complete, you can leave. Otherwise, don't leave. Not available, both of them. Santosh, you have one program in part 6 also, right? Complete that also. Nivedita, Nisha, you please. Okay, Santosh. Nivedita, Nisha. Nivedita, inform Nisha also. Complete that program and inform me. Thank you, students. You can leave. Try to complete the programs by today and update me. Okay? Yes, thank you. Thank you.
Pratape.